everyone in the world believes they're unique in their own way. But this summer, Annie James and Hallie Parker are about to discover
This is so freaky.
they're both unique in the same way.
That's my mom. That's my dad. And you and I are like sisters. Hallie, we're like twins. I have a brilliant idea. I think we should switch places. I'll go back to London as you, and you go back to California as me. If we switch, they'll have to unswitch us. And when they do, they'll have to meet again.
All right. Are they twins? So we're going to start with the idea that sometimes things look an awful lot alike in life, and they're not the same. Heard a story over the summer. Company sent out a part to another company to manufacture, and the part had been changed ever so subtly. These two parts are not the same. One of them has a 15-degree angle. One of them has a 17-degree angle on the pockets here and here. But when the first company made the change, they didn't change the revision number. When the second company got the part, it looked just like the previous part. And so they made the previous part. Over a $10,000 mistake, and both parties, split the loss. But we're going to talk tonight about SOLIDWORKS CAM and CAMWorks, and we're going to talk about the digital thread. And that is the idea that the design intent never leaves the model. And so that's something that CAMWorks, had you made that change to the model, CAMWorks would have alerted you very quickly, or SOLIDWORKS CAM, and it would have said, hey, your part's changed. Would you like to update your toolpath? And probably would have paid for a couple seats of software, right? With just that one thing. So we'll be talking tonight again, CAMWorks, SOLIDWORKS CAM, and your current CAM. Like, I'm not here to convince anybody that drives a Ford to drive a Chevy instead, or anybody that drives a Chevy to drive a Ford. It's really about what tools are best for you guys, and that's what I'm here to talk about. So my name is Jeff Trevorrow, and I own the company CAMS. We're the reseller. We used to be the exclusive reseller for CAMWorks in the area, and that is not the case anymore. But we have been doing it for 20 years, and we're reasonably good at it. We've got some great customers in the area. Gentex Automotive is one of our largest, Precision Aerospace. Nice. And Envision Machine, X-Toll, Coops, some great folks, and we're really grateful for them. And since our business is changing, we're changing with it. And so, again, we've been selling CAM for 25 years. CAMWorks and SOLIDWORKS CAM have been, and really to be honest with you, we partner very closely with Desai Solutions. We like those guys a lot. We've known them for over 20 years. And we want to help them sell SOLIDWORKS CAM. And we will support them, in their pursuit of supporting you guys if you choose to go that direction. When it gets into the higher level complexities, then oftentimes we'll bring CAMWorks in and they work with us. And so it's a very good partnership. We each do what we do best. And then we've also picked up the Markforged line of 3D printers, composite printers, soft jaws, end effectors, CMM fixtures, functional parts, and then the metal printers as well. And we bought 3 of them so we can do parts and things like that as well. And then we bought a couple machines. We bought a 5-axis mill, a 3-axis mill, and an 8-axis lathe. And the reason for that, who can teach you to use CAM software better than somebody who's using it every day? And so, we want to stay sharp, and we want to stay relevant, and we really want to give our best to the end users. And then again, the printing services. So we're going to talk about some of the advantages of integration. There's lots of CAM software out there. Truth is, they're all way more similar than they are different. There's not too many toolpaths. There's not many people who can go, hey, we have this toolpath and nobody else has it. You look at them and you go, oh yeah, it's kind of like that one. It's kind of like that one. It's kind of like that one. A lot of similarities. Even, if you know one of them, pretty easy to know two, because about 80% of the questions are all the same. But when it's integrated, what does that buy you? And again, we talked about the digital thread. You know, you start with this model, and then you carry that digital thread, that design intent, that knowledge that's in the model clear through the end of the manufacturing process. And so, again, we're working on native geometry. Funny thing, we worked with a customer once upon a time that had XYZ brand solid modeler, and and they had the ability to send that thing out with features to other CAD packages and such. But when the CAD package that was reading it read the features from the first one, features would move and come in wrong or wouldn't be there at all. There were no flags. And so you didn't know if that was a good model or not. But when you're working on native geometry, you know it's a good model. And if it's not, then you know that's kind of on the designer. My affinity is for the manufacturing side of the business. You know, I love making chips. I love looking at parts and things like that. And so we say that if you make it to the model, then you made the right part. The software recognizes changes in the geometry. And so again, you're going to be alerted if that 15-degree angle goes to a 17-degree angle. And things like tapped holes. You know, we're going to talk in just a second about, you know, the Industry 4.0 idea and kind of the progression of CAD/CAM throughout the years. But just the ability to have SOLIDWORKS CAM or CAMWorks look at that cosmetic thread call out and go, hey, that's a tapped hole. I know what to do with the tapped hole, and have it do it for you. That's nice. And alerts the CNC programmer again if the part changes, you know, creates associative tool paths. And then, you know, one of my favorites that's really in its infancy is MBD and rules-based machining. And we have a thing called tolerance-based machining as well that's coming out. But if we want to spend just a quick second, you know, talking about the progression of like the CAD/CAM industry, you know, if we went back to the 70s, you know, back in my grandfather's era, they were writing stuff by hand and you know, tape punches and things like that, you know. And then we got to the point where we had 2D CAD. And from a machinist standpoint, when you had 2D CAD, it told you where the XY boundaries were, but you better figure out where the Z is going, you know, because you're going to have to tell it all that stuff. And then the next progression was we had solid models, and solid models, you know, we knew how wide it was, how deep it was, you know, we knew what the radii were in the corners. But you know what we didn't know when we had the solid model? We didn't know what the tolerance was. And so, you know, we all got our model in front of us and we got our blueprint beside us, right? And so, and we're doing this all day long, you know? And so now we've got things like 3D PDFs, and that's cool. That's a great progression. But MBD, model-based definitions, the idea that we put the tolerances right on the model. What a revolutionary idea, you know, right? And so then the next step with that is tolerance-based machining. It's the ability for the software to go, hey, you got this hole, and it's got a 3,000ths tolerance. I can drill it. You got another hole, hey, it's 1 to 2, and I'm going to have to ream that hole. I got another one, it's below 1, and I'm going to have to bore that hole. And then the software can make the intelligent decision based on the rules you give it, not on the rules I give it. I could be way off, but based on whatever you guys want, you set up the rules, and then the software follows your rules. So we'll talk about that today as well. So that's the end of the thing, and let's jump into the software a little bit. So we got a model here, and what we're going to kind of do today is we're going to kind of try to look at, so first of all, who's on 2018 or going to be on 2018 sometime this year? So pretty much everybody. Who's running it already? Okay. And have you guys messed with your SOLIDWORKS CAM standard at all, or anybody? Okay, yeah. So you know what? SOLIDWORKS did you a solid, right? What I'm going to show you in about a second is something that I sold for $5,000 a package for about 19 years. Because once it came out, it was going to be free. It was pretty hard to sell it for $5,000. But, you know, that's why we bought machines, because we got to do something different now. But for you guys, you're getting $5,000 worth of value just for being a subscription customer. And man, I mean, people bought it. I had a $20,000 sale last year based on just what you guys got for free. So I want you to know that's good. we're going to go over here to our configurations, and we're going to change this to our CAM standard configuration. And when I do, it had a few features on the side. We got rid of those. And I'm just going to walk you through kind of what would the process be of programming in CAM standard. So, and by the way, I was originally going to do half the demo in SOLIDWORKS CAM and the other half the demo in CAMWorks. And there's two icons that are different in them. This icon says CAMWorks options. In SOLIDWORKS CAM, it says SOLIDWORKS CAM options. This one says CAMWorks NC Editor. In SOLIDWORKS, it says SOLIDWORKS CAM NC Editor. Other than that, they're identical. And so it just wasn't worth the pause and things like that to get there. So we're going to be on this workflow, this CAMWorks workflow today. And really the first thing we're going to do, let's talk a little bit about the screen layout. And I'll go over more of these in the next session. But we have, here we're in the SOLIDWORKS, side of the world over here. And then when we turn on CAMWorks, and CAMWorks and SOLIDWORKS CAM are both turned on with your add-in manager. And you can have them come on at startup or start them up at will. And when they're turned on, you're going to get 3 tabs. This is going to be our CAMWorks or SOLIDWORKS CAM operation tree. And I'm going to take the name out of it. I'm just going to call it like operation tree. Good for either one, right? And then we're going to have, our option, so we have features over here rather, and we have operations over here, and we have tools over here. You can see our tools are already populated, but they aren't yet used, and things will turn color as we have them and then as we use them. These icons across the top, we can choose our machine, our stock, set up a coordinate system, add additional setup directions, extract machinable features, apply different rules to those features, and on and on. And then some of these things will become available as they're applicable. So let's start with the stock. And in the part environment, you can have a stock model that is derived from a box bounding piece of stock, and that's just kind of a shrink wrapped rectangle. You could have an extruded sketch, you could have an STL model, or you could have another solid model. And that solid model could be either an external secondary solid model, or it could be a configuration of the current part. So if you had a casting or a forging and you made the casting stock, you could have a configuration for that, and then a machined part, and you could both describe the stock and the machined part in one part. So we're going to just go ahead and use the bounding box, and we'll add a little bit of stock on this guy. And so if you hit this up arrow, you can kind of see that stock growing. And then so we'll put it, and if we hit the X, then it just makes it go in both directions. And I'm used to working on 27-inch monitors, so all of a sudden I'm back on this thing and it feels really tiny. So we'll put a little on the top, and then let's put a little on the sides as well. So we got some extra stock in there. Say okay to that. Any of you guys who are machinists, you know that setting our 0 point is going to be really important. So we're going to go in here, and we could use a SOLIDWORKS coordinate system. And you see we've got one in the middle of the part, or we can use a user coordinate system. And we're going to go down here and make a user defined. And nice thing that SOLIDWORKS actually brought, they said, hey, we like what you've done, but let's make it better. And so they went over here and they said, let's give us, let's create a stock, a coordinate system based on that stock bounding box. And so if you look, you see we got all those little nodes we could grab, and you can grab any one of them and put your 0 point there, or on top, center, or whatever you want to do. And then if you're not happy with the direction or something like that, you can go and you can just choose any direction, and it'll set your X along that direction, or set your Y along that, the next direction, or whatever. So you can grab right off of the model. You can change directions. We could reverse that guy, have him go the other direction or whatever. So let's say okay to that. And then finally, let's go and let's define our machine that we want to cut it on. SOLIDWORKS CAM standard is 2.5 axis milling plus some light 3 axis milling in the part environment only. And so we just go ahead and grab this mill part, and let's say select and okay to that. Go over here, let's just take this default tool crib or group of tools. We're going to go over here and we're going to choose the Brian post processor. So Brian is a guy who works for us. Post processors, who knows what they are? Anybody in here? Who knows that if they're not right, they really stink? All the same people who know what a post processor is. Yeah. Yeah, thank you. Thank you. He delivers more value than, I mean, I actually lose money on posts every year, or break even at best. But you know what? I have really happy customers, and that is the difference. He is phenomenal. He's one of the two best in the world at writing posts for CAMWorks. You know, there's other great guys for other packages and things like that. So we'll take the Brian post. He gives you lots of nice options in terms of like your posting tab. You know, he tries to do everything that CAMWorks will do that your machine will do and puts that in the post. So let's say okay to that for now. And at this point, you know, really we're ready to go ahead and say extract machinable features. And I'm going to make sure that my message window shows up. So if you probably won't be able to read this, but it'll kind of tell you what's going on. And we'll pin that guy in place. And so let's say extract machinable features. And it'll tell you that it's kind of initializing the engine. And even as I speak now, I know that I got it wrong. I told them, I did a little demo for these guys ahead of time, and I was like, I'm going to get this wrong when I go to do it. Because you can turn on your options for the features that are found or not found. It might work because we're in the part mode, not the assembly mode. And it did. So here's what CAMWorks found. It found a face feature. And if you look, it knows where the top of the stock is, knows where the top of the part is. It also knows the extent of the stock. It found a part perimeter feature, and so it knows, you know, once again, where the part is, where the stock is. And we're going to drag that guy down to the bottom. And then it found a whole bunch of pockets, and if we hover over them, you can kind of see them lighting up and things like that. You could tell it to highlight all the recognized features, and they'd all turn blue, or highlight all the unrecognized features. And then it found some holes. And after each of these guys, you see something in parentheses. So this says rough volume mill, rough finish. And so you can name your rules anything you want. Like I could make them Jeff 1, Jeff 2, Jeff 3, but after about Jeff 10, I wouldn't remember what they meant. So I try to give them something that's a little bit expressive or that jogs my memory to know what they do. But these are and you know what? Every one of you guys who works in a machine shop here or runs a machine or anything like that, every company in America has rules. Most people don't capture them. Most people just have the rules and you know it and you know it and you know you have a different set of rules and you don't care about the rules and so it's all over the board, you know. And so what, you know, and this guy's going to run it at 100 inches a minute and this guy's going to run it at 50 inches a minute and you know it's all over the board. And so with rules-based machining, you know, you don't have to conform to them. You can always change them, but we try to give you a starting point. And then every company can refine that starting point, you know, and refine, this is how we do pockets. Hey, when we do pockets, we always go in and rough with a big tool. We rest rough with a smaller tool. We finish with a tool, and then we edge break it. That could be a set of rules. But whatever it is, it's just the ability to capture it and apply it over and over and over again. So when these features are in blue, it tells me that I have no operations waiting for me. So I go over here and I say generate an operation plan. Takes all those features out to the database, and then the database sends back the operations. If we go back over here to our feature tree, see how they all turn black? So they went from blue to black. So we know now that we have operations for everything. Now our operations are blue. And what that tells me is I have no toolpath. So if I want to go up here and click on that and say generate toolpath, there you get your facing pass across the top and your operation turned black. If I look at my tool tab, here's all the tools that I'm using in black and all the tools I'm not using in blue. And so let's just go ahead over here and we'll say generate toolpath for everything.
Now is this generating the toolpath based on your rules predefined already?
Yeah, based on and you know what? Like the truth is that I just did something that I didn't intend to do on the SOLIDWORKS standard demo. So you'll see that it says volume mill. Who knows what volume mill is? So a few of you guys. Volume mill, I mean, so truth is, I used to tell people this. If you bought $5,000 CAMWorks, and back then it was about the $1,800 volume mill add-on, you'd be at about $6,800, and I'd say, you know what, the volume mill can probably pay for the whole system in the first 3 to 6 months. Volume mill It's a volumetric, high efficiency, ultra high efficiency roughing algorithm. It's only for roughing. You got to have some RPM, you got to have some feed rates on your machine to make it worthwhile. But if you do, then you can expect 2 to 5 times faster roughing cycles. You could expect 3 to 8 times better tool life. My first customer who bought it, they made a 65% profit on their first job. He called me up. He's like, I hope you don't sell that to anyone else. And so we did. We sold it to a lot of other people. But you know, that was amazing. And I had another guy bought it recently. He was cutting Inconel, and it was taking him 1 hour to rough the part. And he was getting 1 part per tool. Volume mill, 15 minutes. And he still only got 1 part per tool. I don't know why, but he probably just was like, I'm saving enough money. I don't care. I'm put a new tool in there, you know. So it's for real. But here's the catch. It's not in CAM standard. You got to go up to CAM professional to get it. And you know what though? You're getting, so you can buy the whole CAM professional for $2,400, you know, $595 or $600 for subscription. And used to be, it was like $1,800 just for the volume mill, but you also get a whole bunch more. And we'll talk about that in a minute. So let's go and let's get rid of that, that volume mill toolpath. So let's go to our default strategies here. And let's say, hey, when you find irregular pockets, instead of volume mill, let's make it just a standard, you know, rough finish. What's that? Oh, yeah, way better than the old where you had to go through click, change, click, change. We do learn. It takes us a while, but we do learn. So let's regenerate our operation plans. And we have a choice of updating or regenerating. Let's just regenerate everything. This is the slowest fast computer I've ever owned. So let's go ahead and generate a toolpath for everything. And you know, right about now, there should be a whole group of guys that are going, it's way too automatic. You know, where's the control, right? And but you can go in and you can double click on the operation, and here's all your standard parameters, right? We could go and we could change the tool, grab it from our tool crib. We could change the holder, you know, change our protrusion amounts, you know, probably change the length of that tool overall, right? And you can, you know, and again, I can't stress enough, it's really all the standard questions you're used to with any other CAM system. Feeds and speeds, you know, they can be based on a library that you can set them up per operation or per tool. Your style of roughing, do you want to pocket in, pocket out, zigzag, spiral in, spiral out, offset roughing, or if you upgrade, volume mill. And then NC tab, you know, what's your clearance plane, your rapid plane, what are they relative to? And it's just all the same things you're used to seeing. How do you get into the pocket? You know, I want to spiral in, plunge in, entry drill, all kinds of things. Yes?
A quick question for you.
Yeah.
I don't say what other software, like other software you use, if you don't set your rapid plane higher than say the top of your part, it goes right to the top of your part. Is this because it's a solid and you know that not to do that?
No. It's because our rules were set up so that we didn't do that. If we'd have somehow set them up, yeah, it's not really, I mean, of course your simulation would show you that and you can get a nice crash, you could pause it, you could do whatever, you could probably put a sound on it. But it's because we set the rules up that said, you know, rapid planes above the top of the stock and clearance plane above the top of the feature.
You don't have to worry about it.
You know, if it is true. So I was at Gentex today and they said we are this close to having all our standard stuff automated. You know, just where push a button. Another one of our customers is PCS Company, and they're a division of Misumi. PCS owns 35 seats of the most popular CAM system in Michigan. Most of you probably know what that is. But, you know, they, and it's a great CAM system, you know, but they got their programming time down with 8 programmers, 2 shifts, 35 seats, to 60 minutes or 1 hour per part. They bought 2 seats of CAMWorks, 2 programmers, put about 6 months of refinement in because they're really trying to automate their whole system. We even wrote a thing called a color-based macro. One of the guys from Precision Aerospace wrote it, yeah. And so he's a genius. one of my favorite guys in the world, you know. And but PCS company today, 15 minutes per part. And so, you know, it's all based on good rules, good feature recognition. And, you know, I guess the parts have to fit. You know, if you're doing 5-axis simultaneous, feature recognition isn't going to do anything for you. But it's still, the tools are all still there to do it, you know. So anyway, let's say okay to that guy. And we'll change that tool for everything that's using it. And let's go over here and let's sort our operations. And so, and once again, it is, I'm dealing with, so we could come over here, and if we had indexes, we could sort by and across indexes. Tim Vandertoorn from Envision, they got a beautiful new Makino horizontal over there. So if you guys are looking for some fast horizontal work, they'll do a great job for you. And but I was asking him today, how's it working for you? He's like, great. You know, the optimization, you can sort by index, sort by tool change, you know, sort by and across indexes, things like that. And then we can go over here and just tell it what we want to do first. You know, do we want to do our whole work first, then our milling, or vice versa? We also want to sort it by tool, and we can apply that. And if we like it, we can say okay. If we don't like it, we can undo it. And then you can still drag and drop. So if we want to do our, oh, you know, I forgot to take my volume mill off of that. Sorry. You're going to get to see a little volume mill. Didn't mean for you to. And let me find that contour pass. And let's take that guy and drag him down after the rough. Now I can tell already that I'm not going to like this contour pass because the rules in there have defined like the depth of cut and things like that. So I know the tool is going to be too small. But let's go ahead and let's run the simulation first, and then we'll go through that. So you can make the stock solid or translucent or whatever you want to do. You can show the shaded part underneath if you prefer that. Whatever you want to do. And we'll go ahead and we'll slow it down just a touch. When the tool is red, it's doing a rapid move, and when the tool is tool colored, it's doing a feed move. Now I usually like to show the stock as solid, and whoops, I don't want to do that. So we'll do that. Let's turn the part off. And this is more my favorite way to show it. And so, you know, I'll tell you that, let's see how we're doing on time. Some of the, this part had some 448 tapped holes in there. It automatically saw that with the, with the thread, the whole thread recognition and things like that. So it automatically did that procedure for us. And we can combine these operations. So we take like operations. You don't want to have to change 8 operations, you know, to do the same thing. So we can combine them, and when you do, it'll automatically sort that flow of cutting too. So you're going from closest to closest. Now here's the volume mill. You know, it's doing chip thinning going into the cut, chip thinning coming out of the cut, constantly varying the feed rate in order to keep a constant volume of material removal. And then what it wants to do is a racetrack toolpath like this. And then there's our too small tool. I left it too small for a reason. I wanted you to see it. And so how do you change tools? You could go into the operation, and then you could choose the tool that you want, or you could just come over here and you could say, oh, hey, there's that 1/4-inch tool. I'd really rather use my 1/2-inch tool, so you can grab it and you can drag it down to your 1/2-inch, recalculates your tool path, and away you go. Let's go and let's combine those operations. Actually, maybe we won't. I'm going to do almost this identical part in the Pro demo, which we're going to do next. So I feel like it's going to be kind of redundant, but I just want to show you some of the differences. Let's go ahead and post the code out. And let's put it under G code. And let's go ahead and let's have it run the open up the code in the editor when we're done. And you can have it show the code or you can have it not show the code. We'll just let it show the code. And you can kind of see it scrolling by there. You could also show the moves. That's fun for about 0.5 seconds, and then you don't want to see it anymore. And then here's the editor. And this is the Simko Editor. A lot of you guys probably seen it, you know, where it shows you the different colors and things like that. It's kind of a light version of it. It's got some backplotting and stuff in it. You can get a pretty inexpensive upgrade. You even see some solid simulation through G-code, which is nice. So, any questions on that so far?
When you say the solid simulators, that's like Vericut, basically?
And you know, that's a great question, is that we do actually have 3 levels of machine simulation. And so most people are doing apt-CL based simulation. We have that. It's great if your post is perfect, and if your post is not perfect, you could still get a crash. And then we also have G-code level simulation for CAMWorks with our virtual machine. And then you know, we have the just the cut simulation you saw before. And then we're also personally carrying the Simko line of simulators that are just coming out. And so they're taking, you know, Vericut, I mean, great software, very expensive. You spend 30 grand in a heartbeat, you know. And so Simko, they're going to be probably, I mean, under 3 grand for sure, probably under 2 grand in some cases for true G-code machine simulation. That's unheard of, you know. Ours is more than that. Yeah.
Is that drawing the whole machine or just like your
You can.
screen?
Yeah, you can. They're starting with Heidenhain, I believe, because they're from the Netherlands or whatever, and it's very popular in the area. But they're going to do all of them, and they are really bringing the price point down. And the thing is, same machine models as any of us use. Same machine models I'd use for CAMWorks, for Vericut, for anybody. So the models look the same. Then you just got to get the kinematics. It's kind of the reverse post-processor, right?
Right.
So, all right. So there's our code. And any questions on this guy, on the CAM standard?
I don't want to get ahead too ahead of you, but at some point, are you going to show what the tree looks like, the geometry tree?
Yeah, sure.
Could you do that now?
Yeah, sure.
And maybe would you show maybe like a simple modification?
Yeah.
How that affects the...
Of course. Yep. Let's go in here, and here's our cut pocket. Let's go and let's edit the sketch that was used for this cut pocket. And let's go in here and let's just change that angle. Let's make it a 19-degree angle. And so you see it kind of narrow up. Let's exit out of our sketch. Propagates that change. You can kind of see how these guys got longer. Maybe you can tell that. And this is the magic right here. CAMWorks. And you get this message. That's the $12,000 message right there. That is, hey, wait a minute, the part changed, you know. So we say, okay, let it go ahead and rebuild. And I'll show you one other quick thing when we'll run a quick simulation again.
This is all standard, right?
The only thing that's not in standard is the volume mill outside roughing. I didn't change that back, so let's get rid of it. I'm going to turn this guy off so it doesn't stay up. I'm going to get rid of this guy so it doesn't stay up too. Let's go into our simulation. Even in tool mode, we can go here and we could say, hey, update the stock every, let's say every 20 moves. And then we'll just have it run to the end. Let's set it on full speed. So pretty quick. And then you can do a comparison between the modeled part and the cut part. And so looks like we got a little extra stock left on our counterboard holes we'd want to address. But otherwise, our pockets are correct. And so it updated the toolpath to correspond with the change in our pocket.
Can you put in your post toolware, you need to just rerun a pocket or whatever?
Yeah. So if you're like with probing, that is something that we have a little bit today, more coming. And so if you were talking about probing a pocket and then rerunning based on the probe data, that's not something we could probably do today. I mean, we could, I just bought machines and I bought, you know, Renishaw probes for all of them, and I bought the Renishaw software. And so we're going to figure out what's the best way to integrate that with what we have today. But then CAMWorks is also working, the truth is that some of you guys have probing routines in your CAM software today, and you're in your CAM software, then you go into the probing routine, it's like you just went into a whole new house, right?
No, but what I'm saying is, like, let's say I measure that pocket and it's supposed to be a 3/8 counter bore, plus or minus 1,000. Can I rerun just that toolpath while it's already posted to the machine to get to my tool to fit to that, or do I gotta go back into the post and line to my tool or whatever I have to do to get it to fit?
Well, that's more a machine tool thing, right? Because if you have the probing, so you went in on the machine, you had the machine go probe it, and then it found that it's undersized. If you're oversized, you're done, right? But they found it's undersized, so I have to run it again. So what the probing software is normally doing on the machine is changing the comp register, right? So then so yeah, of course it would rerun just that one, and we could do whatever you need in the post, to call that routine, if you had the routine stored on the machine or something like that. Are you with me? Am I
Yes
answering?
and no. Yes,
Okay.
I understand what you're saying.
Or you can post out just that operation.
Yeah, that's.
Mhm.
Or if the whole
Mm.
had 40 programs posted out, can I go to tool 20, operation pocket 1 or whatever, and just rerun that pocket?
Just repost this one right here.
If it's already posted, can I just rerun that? Can I go right in my post right now, go T20, and just comp my wear myself manually and rerun that?
Depends on your machine controls.
Yeah.
Depends on what you're.
But some posts don't read wear.
Well, so let me say, I normally for us, it's more on the machine side at that point. We just did a rotors. You guys know the rotors machine?
If I run.
Yeah, so we just did a rotors post, and that machine checks the wear and it substitutes out the tool. Yeah, so the rotors machine, if your half-inch tool's got too much wear on it, it'll just put the next half-inch tool in and rerun. Yes, we have that
Okay.
in the if you're talking about for the rotors, yeah,
It
we just
wasn't
did
for
that.
Rotors, it was for, even for a regular Haas or whatever, if we go in, we have yeah. No, it's not for toolware. I don't know how toolware is posted out.
Well, it doesn't post tool wear, so that we're going to give you, your comps. We'll put out your cutter comp.
It turns ClearCop on or off. So
Yeah.
the comp of the machine does it for you.
And we'll call it whatever comp register number you want. We can work with you on it, and if it's something that I think we're close. I don't know.
Just running a lot of stainless. We run into, if it's a long run or whatever,
Yeah.
we may have to run that one pocket 2 or 3 times, and we don't want to change the tool because it's still good enough.
Right.
Being able to comp that tool 2 or 3 thousandths maybe in the machine and run it again.
Mm-hmm.
And I just don't remember the post it for a tool where a cutter comp.
Okay.
You got the post. I don't want to say the software, but the software we're using now.
Yeah, sure.
I could turn computer on, which will just run whatever I define my tool as.
Yep.
Or if I turn wear on, it'll comp from that diameter plus or minus for that hole.
Okay. Okay.
Rather than looking at the register for cutter count diameter, it's looking at it in the post.
Correct.
Okay. I'll probably have to dig into that a little bit with you and just maybe see a little bit more about how it works now and then what we can do that would be comparable. So I got about 450 customers and thousands of machine tools that we're running. So I feel comfortable that we can, help you get what you need. So, all right, let's look at this part let's look at it. What would the differences be if we went into Pro? So I'm going to keep the same part just so it keeps some similarity or familiarity. And but let's grab it in the assembly environment. So in the assembly environment, we've got a whole bunch of solid models in here. Let's just move real quickly through that part programming process again, because I want to show you guys just a couple other things before I'm done. Let's go. We'll do a new configuration on this guy. And so the first thing we'd do is we'd come in here and we'd say manage parts. And so we'd want to let the system know what's a part and what's not a part, right? And then the next thing we're going to do is we're going to go define our stock. And in this case, we'll just choose another solid model. So we choose that guy and it maps the stock out on that onto that piece. So we'll say okay to that. Let's look at our rules real quick here. So for our CAMWorks options on our features, we're going to look for holes, non-holes, bosses, face features, part perimeter features. And when we find a part perimeter, we're going to treat it as an open pocket, which means it's going to machine all the material away rather than just cut around it. And we're going to say anything up to 1.25 inches can be drilled. Anything over 1.25 inches we want to mill. And let's say that we have to have 91 degrees of an arc before we treat it as a hole. And then we're going to condense split holes. So if we have a hole that is collinear or whatever, that goes here but has a break here and goes here, we're going to drill that all as one hole, and we'll recognize it that way. I think that should be good. So let's say okay to that. And let's go over here. Let's create our coordinate system. And let's put it based on the stock. Let's put it right there. Let's make our x-axis, along this edge here. And let's make our y-axis along this edge here. Let's reverse that guy. Or actually, let's reverse this guy, rather. There we go. Say okay to that. And once again, I want to stress that you can use the CAMWorks, SOLIDWORKS CAM coordinate systems, or you can use your SOLIDWORKS coordinate systems, either one. And let's go into our machining environment. This time we're going to take our 5-axis mill. So let's select that guy. Let's go over here. We'll take that same tool crib. Let's go over here and take our 5-axis post. And let's make sure that we've got our 5-axis mill, and we're saying that we can rotate 360 degrees, we can tilt plus or minus 120, and you can set those limits up for your own machine. And we're going to be rotating about Z. And on this machine, we're going to use a head table machine. So like the new, some of the Moris or the Hercos have them, where the head swings. So let's go about our Y-axis, and let's reverse that direction, and let's say okay to that. And then the system is smart enough to know that when we extract the machinable features, it's going to give us the things that are accessible. And so let's go ahead and we'll say extract machinable features. I'm going to try to go really fast on this because there are a few other things I want to show you guys, and we only have about 10 minutes left. So let's drag that guy down last. Here on the side, we found a face feature, and I don't really want to use the face feature, so I'm going to delete that guy out of there. We found a part perimeter feature. I don't want to use that. You can also control select the things you don't want to keep, hit the delete button, get rid of them. And normally I would come in here and I'd kind of rough off this material and I'd create a feature, but I think we're going to run out of time for doing that, so I may just let it go by itself. It'll look a little funky, but you'll get the idea. And so let's go ahead and generate operation plans for everything. And let's go ahead and generate Toolpath for everything. Now, I'm going to go ahead and I'm going to sort operations real quickly. And then I'm also going to condense. So I've got, here's my outside rough, and then here's all my different pockets. And you can see it's rough mill 1 down through rough mill 8. So I'm going to shift select these guys, right click, and I'm going to pick combine operations. And I'm just going to say, okay. And so that condenses us down into one roughing pass. Oh, you know what we did too? I'm sorry, that's my fault. Is that I didn't pick by tool, but I want to change the tool anyway. I've got this 3/4 tool over here, and what I really want to do is I want to run a 1/2-inch tool with my volume mill. One of the things that's nice about volume mill is you're always trying to achieve at least a 2-to-1 depth to diameter ratio. So if I'm using a 1/2 inch, I'd like to go 1 inch deep. If I'm using a 1/4, I'd like to go 1/2. But I've seen guys go 6-8 times diameter. And you know what the weak link becomes? Your holder. It's trying to pull the tool out of the holder because you have so much flute engagement. And so, but the great thing about smaller diameter tools, heck, a lot cheaper. You know, you start buying 5/8 and larger carbide tools and it gets a little pricey, right? So, so we got that guy. Let's drag this guy up here too. And you'll see that volume mill is actually recalculating. Now, we are cutting into our vise, and there's a couple ways we could get around that. You guys ever hear the saying, slow is fast? So right now I'm trying to go fast and I'm going slow. So I should be going slow and then I'd be going fast. Yep, but if we go to this part perimeter feature, we can modify this part perimeter feature, and we could say, hey, instead of going clear down to the bottom of the stock, I just want to go down to the bottom of the part. And then you could put an offset in there. So we could say 0.025 to go past the bottom of the part just a little. And we could say okay to that. And come back over here and hey, look at that. It's nicely changed we might still be just a little too low, it looks like. It'll be fine. Well, it'll be fine for the demo, right? I really enjoy that comment. That was awesome. Yeah. Anyway, and we got some Toolpath on the other side. We're going to be flying right through the stock on the other side. Normally I'd clear it away, but I want to show you a couple other things. We're running low on time, so let's do this. Let's go into our simulation or our setup, and let's let it know where the vise is. Say okay to that. Go into our simulation. And for those of you guys who are not familiar with the volume mill toolpath, one of the things I'm really trying to highlight here is that. And so we're going to run to the next operation. We're going to slow it down. We're going to have it update the stock every move. So there's our facing tool. All right, so with volume mill, you could do an entry hole or you can spiral a ramp, but you can see it's gradually like spiraling its way out until it can no longer do that, and then it's scalloping out the material. And it looks like it's staying at depth, but it's not. It's doing a floor clearance move when it comes up, goes back to the cutting position. So it's actually in its cut, arcs out, ramps up, does a high feed move, and then arcs back down into the cut, goes through the cut. Those of you guys who have run it, I've had guys cutting, D2 tool steels, and the guy next to him think they're cutting aluminum. It just sounds so good. You never hear that heavy buried sound in the corners. It's a beautiful thing. And to be honest, so let's talk a little bit more since we're starting to hit our limit. So SOLIDWORKS CAM Pro. So Joel, Desai Solutions. How many of you guys know Joel? One of my favorite guys in the western part of Michigan. No, he's one of my favorite guys. He's a great guy, and he does a great job for his customers, which I really appreciate. But we're helping Desai, to sell this package for those of you guys who are Desai customers. And this package you can buy, and I'm not trying to sell you anything. I'm just trying to tell you my experience. So if you get SOLIDWORKS CAM Pro, you're going to get 2.5 axis milling in the part and the assembly environment. You're going to get 2.5 axis volume mill. You're going to get turning. You're going to get some 3 axis cut cycles. Kind of maybe enough for like some aerospace type parts, but not enough for doing molds. And literally when I probably used to sell that for around $7,500, and now it's $2,400 plus subscription. And so it really is a great deal, and it pains me to say that, quite honestly. I've got 2 kids in college, trying to pay the bills, and getting tight. So anyway, but they really gave you a lot of value. The whole proposition is changing in the market, and so I'll show you a quick LAIV part in just a quick second, and let's let this guy run to the end. And if,
Too, so it knows that this jaw was there and it wouldn't have cut the jaw anyhow, right?
yeah,
Avoid it.
yeah, yes.
It missed, it's fine.
What's that?
It doesn't look like it cut it. We're alright.
We're close. Oh, you know, we're close.
Definitely went under.
Yeah, yeah. That was probably, I probably fat fingered it on my part. But anyway, we get the index moves in there as well, and you know, and then the package CAMWorks is actually available up through, you know, clear up through 5-axis simultaneous. So we don't really have time to run through the programming. You could really literally program this guy up in about 15 minutes. But we've got a multi-surface feature here that's got all the different features. You know, we went ahead and I had a certain rule that kind of generates one of everything. So I've got some volume mill toolpath. This is 3-axis volume mill. That is still an additional upgrade. And then there's some other toolpaths in here. So you can see we've got a volume mill rough. We got a rest rough that just finds the remaining material. We got a Z-level finish that's based on slope. We've got a pattern project, once again based on slope, could also be based on contains. We've got a flat area finish that's looking for the flats, and then we got pencil mill coming in here, maybe going a little deep on some of those guys. Let's run through it real quickly. And by the way, I did actually bring some stuff here today. Here's that same part. Cut it at a machine tool open house. You guys can pass that around if you like. And so volume mill goes to full depth and then it steps up. And so then we're going to come back with our rest roughing and we're going to knock down those steps a little bit.
How long did it take to do this?
You know, out of aluminum, not very darn long. Yeah, the volume mill actually could have roughed it all out in under 5 minutes. We had to slow it down so people could see it, because otherwise, you know, not everyone could even get a look at it. And chips were flying. But I'll tell you, I say this. I've been in the business for 25 years, as I said. There's only about 5 really big game changers during that whole time. The first one was Windows NT, because any of you guys old enough to know that you had Unix and you had DOS, and there was not much in between, nothing in between. And so then Windows NT brought the high-end guys down to a platform, the low-end guys up, and gave you the common platform. Best thing that ever could happen for design and manufacturing software. But you know, there were a few other things. We went from machining surfaces to faceted data, got a lot faster, a lot more reliable. That was another huge change. But volume mill, it is a game changer. And if you're not running it and you have the RPM and you have the feed rate, man, worth looking into. So let's speed this guy up a little bit. Actually, there's like a turbo mode. So if we back it up, put it in turbo mode. So this would be CAMWorks functionality. You do also get the turning, and the turning works, you know, very well also, pretty quick and easy.
The turning, do you get live tooling?
Yeah, well, the live tooling would be a CAMWorks. So for SOLIDWORKS CAM, it's 2-axis turning. But then CAMWorks takes it from 2-axis to mill turn to subspindles, upper and lower turrets. We can do 2-channel synchronization. So we personally just bought a, you know, an 8-axis lathe. So we got main spindle, subspindle, C and Y axis on a single turret. So.
Your handoffs are synced pretty good? Your handoffs
Yeah.
are synced?
Yeah, so we've got a subspindle manager, and it has a nice graphical display of coming in, grabbing the part, pulling it back, and you can see which chuck is active. You can set, you know, you can set every command you need for that. So